So now we have studied what is integral. Let's recall it. Integral of function fx equals to some function capital Fx plus c. This means if I differentiate this portion, I must get this. This is differentiation procedure, you know. This is the differentiation. Integral of one function is some new function. That means if I differentiate this right hand side function, I must get the given function. That's what it is called, integral of fx. And method of finding is called integration. So integration is a procedure of getting integral. Where c, c is called the constant of the integration. Constant of the integration. And we'll see later on there are two types of the integral. Here it is called indefinite integral. Indefinite integral or integration. This is indefinite integration procedure. So this is sometimes called indefinite integral, or primitive. This is also standard terminology, primitive or indefinite integral. Later on we'll study which is called definite integral, which we'll see. Definite integrals, that also we see in this chapter. Definite integrals. Here we have indefinite integrals. Okay, so for example, now if I want to write integral of e raised to x, it is e raised to x, the prepared formula, plus c. Why integral of e raised to x is this? Because if I differentiate this, I'll get this. Next, if I take 2 raised to x, you have ready formula for this exponential function. 2 raised to x upon log 2. Here b is, it is understood, e plus c. Right. So this. For example, let me write integral of cos x. That means you find one function whose derivative is cos, which is sin x, plus constant c. Why integral of cos is sin x plus c? Because if I differentiate this, I'll get this. Okay, this much just to revised from the last session. We have done all standard formulas. Now we go for working rules. So working rules we did for differentiation. Here working rules for integration. Integral of two functions fx plus gx, the whole dx, equals to, you can do individual integral of fx plus integral of gx, as we did in differentiation. You can take this integral sign inside. Even the same result is also true for if you have minus here. So minus. This can be generalized for three functions also, remember. Second rule, if you have constant into function, as we were doing in differentiation, that constant will come out and just integral of fx, where k is constant. Right? Constant come out directly from the integration and just integral of the function, as you did in differentiation. So we have only these two working rules. We don't have product rule and division rule. In differentiation you had all four working rules, remember. Here we have just these two. If you have plus or minus, you can take integral inside. If you have constant, you can take it outside. Like this. If I take simple example here, suppose I have x squared plus, let me write 1 upon x plus 1. Suppose I have three functions. Integral of these three functions. All are standard functions, So what you can do is, by first working rule, integral of x squared plus integral of 1 upon x plus integral of 1. This is what the first working rule says, as you were doing in differentiation. You can apply integral to each of these functions. What is the integral of x squared? Raise the power by 1. Now you know the formula. X raised to n plus 1 upon n plus 1, if you remember. raise the power by 1 divided by the same number. If you differentiate these, you will get exactly this. What's the integral of 1 upon x? You know, log of mod of x. As I told you, when you write log something, then it has to be inside the modulus. Plus, what's the integral of 1? Find one function whose derivative is 1, which is x. What's the derivative of x? 1. So x. And at the end, you are going to write just one constant c. Not one constant for this, one constant for this, one constant for this. Not like that. Just a single constant at the end. So this is the required integral. Indefinite integral sometimes. If I differentiate this portion, if I differentiate this, I'll get this much. Right? That's the meaning of integration. Just to remind you, you know it now very well. If I differentiate this portion, I'll get exactly this. Okay, let's go to one more example. Suppose I have 4 sec square x minus, let me write 2x, like this. So two functions, 4 being constant, you can keep it outside, 4 sec square x minus 2 being constant outside, integral of just x. Both rules have used. Your minus, so integral sign inside, 4 and 2 both were constant, so I have taken both outside the integral. 4 as it is. What's the integral of sec square? 10x. Find one function whose derivative is x square, which is 10, minus 2 into, what's the integral of x? You know, x square by 2. Simple power function. What's the derivative of x raised to n? Raise the power by 1 divided by the same number. What is power here? 1. So 1 plus 1, 2 by 2. Plus at the end, constant of the integration. So finally, you will get the 4 10x minus 2 will get cancelled, x square plus c. This is the integral of this function. If you want, everywhere it's not important, but if you differentiate this, you will get exactly this much. Right? That's what the meaning of indefinite integral of this is, this antiderivative procedure. So before I go to first exercise 7.1, I'll just state a simple result that says that if integral of fx is big Fx plus c, if you have this, then integral of f of, instead of x, you are writing linear function ax plus b. So what it says here, function is composed with linear function. Then integral is also same, f of ax plus b upon the coefficient of x. What's that? That is a plus c. This is what the result says, where c is constant of the integration, remember. What this result says, if you know indefinite integral of fx, then if the function is composed with only linear function, remember I'm emphasizing for linear function, then integral of, you can write directly, that is the same function upon the coefficient of x, which is a. A should not be 0 here. Okay, like this. If I take an example, you will understand. You know integral of sine x. What's the integral of sine x? Which is nothing but here minus cos x plus c. That you know, this is our standard formula. Now, if I want to write integral of sine of, let me write 9x plus 1. You see, now this sine is composed with which function? This linear function. Then how do I answer this? The same method. Minus cos of 9x plus 1. You see, I have copied the function. What's the integral of sine? Which is minus cos, this inner function as it is, upon, this says that the coefficient of x. What's the coefficient of x? Which is 9 plus c. So this is integral. How do you justify? You know, antiderivative procedure. You differentiate this correctly, you will get exactly this. You can verify. By chain rule, you need to do this. Okay. One more example. If I just recall, integral of e raised to x is e raised to x plus c. So now if I want to write integral of e raised to, let's try 2x plus 1. Now you see here x, this 2x plus 1. This is a linear function. So how do I write integral e raised to 2x plus 1 upon coefficient of x? What is that? 2 plus c. So this is answer to this. Function is composed with linear function. If I have like this, for example, e raised to x square plus 1, then this concept cannot be used, remember, because x square plus 1 is not a linear function, not a linear. Then something else should be done. We'll do later on. Not a linear function. When you use this concept, then the function should be composed with linear function. Suppose I want to answer this sec squared, let me write 2x. Now this is a linear function. So as we were doing in differentiation, this is like chain rule. You imagine this is x. What's the integral of sec squared, which is 10x? So 10 2x. In differentiation you will write into 2 by chain rules, but here you need to write upon the coefficient of x, which is into 2 plus c. Differentiate this by chain rule, you will get exactly this. One more further to clarify. Suppose I want to integrate this 2x plus 7 whole raised to 11. Now what we do? You see, base function is linear function. So you can imagine that as x, this linear function. Right? If you have linear, you can imagine as x. That's what this result says. So what's the integral of x raised to 11? X raised to 12 upon 12. So 2x plus 7 raised to 11. Raise the power by 1. So 12 upon 12. As per this result, upon the coefficient of x. What's the coefficient of x here? 2. So into 2 plus c. So your final answer is 2x plus 7 raised to 12 by 24 plus c. This is your answer. You differentiate this by chain rule, you will get exactly this. You can verify. Exercise 7.1, first question here. Question number 1, integral of sine 2x. So you know how to integrate. You cannot use here that half angle formula. Imagine this is like x. What is the integral of sine? You know, minus cosine 2x upon the coefficient of x, which is by 2 plus c. This is your answer. Remember, this concept is useful only when you have linear function. If you have like this, concept cannot be used. Suppose like this, then this way integration should not be done, because this is not linear function, remember. So be careful. Question number 2 here, second question, cosine 3x. So cos function is composed with linear function. What's the integral of cos? Which is nothing but so here sine 3x, integral of cos is sine upon the coefficient of x, which is 3. So by 3 plus c. Third one, integral of e raised to 2x. This is linear function. You know, integral of e raised to x is e raised to x. So e raised to 2x upon the coefficient of x, which is 2 plus c. Fourth question, integral of ax plus b the whole square dx. So here this is, you know, linear function. So we imagine this as x. What's the integral of x squared? That is x cube. Ax plus b the whole cube upon 3 into coefficient of x, which is a plus c. That's your answer. Raise the power by 1. 3 divided by the same number upon the coefficient of x, which is a. You differentiate this, you will get exactly this. You can verify. Question number 5 here, fifth question. Integral of sine 2x minus 4 times e raised to 3x the whole dx. This dx is always with this integral sign, remember. You can use the working rule. I'm writing directly here. What's the integral of sine 2x? As we wrote in the beginning, this is minus cosine. This is a linear function. 2x upon the coefficient of x, which is 2. Minus cos 2x by 2. minus 4 as it is. What's the integral of e raised to 3x? E raised to 3x upon 3 plus c. So this is your final integral. Y upon 3 coefficient of x. 4 being constant as it is, like differentiation, plus constant of the integration, remember. Y upon 2 coefficient of x by 2. Okay. Question number 6 here. Sixth question. 4 times e raised to 3x plus 1 the whole dx. So 4 being constant as it is. What's the integral of e raised to 3x? E raised to 3x upon 3 coefficient of x. What's the integral of 1? Which is x, because derivative of x is 1 plus c. So this is your answer. Next question. Question number 7 here. Integral of x square into 1 minus 1 upon x square. Now here you have product of two functions, but we don't have product rule and so on. So we need to simplify this. So if you simplify this, after taking LCM, x square will get cancelled. So just x square minus 1. X square, and then this will get cancelled. So now integral of x square, raise the power by 1 divided by the same number by 3. Integral of 1 is x plus constant of the integration, so plus c. Question number 8. Integral of a raised to x plus bx plus c. Your integration is with respect to x. So these a, b, c all are constants, remember. A being constant as it is. Integral of x square, x cube by 3. Raise the power by 1 divided by the same number. B being constant as it is. Integral of x, which is x square by 2. C will come out. You are just left with 1, and integral of 1 is x. C as it is. Integral of 1 is x. It's like this, remember. C dx. Last time I'm talking. So c will come out, integral of 1. What is the integral of 1? Which is x. So that's why cx, like this. C is already there, so I'll write c dash. So you have ax cube by 3 plus bx square by 2 plus cx plus c dash. You differentiate this last expression, you will get that bracket. That is a given function. Okay. Question number 10, 9th is very simple, you can do it. 10th question, root x minus 1 upon root x the whole square. Now here you cannot do the like differentiation, you cannot imagine these as x and so on, remember. You need to simplify. There is no other way, remember, right now. So I'll open like a minus b the whole square. I cannot do this question, remember, like this. You see here I did directly because this was linear, remember. So I could take this as x and then integrate it. Here it cannot be done because this is not linear function. So I need to expand it using a minus b whole square. So a squared, that is x, plus b squared, 1 upon x, minus 2ab, so just 2. And now we integrate it. This is just by using a minus b whole square formula. What is the integral of x? X square by 2. Raise the power by 1 divided by the same number. What's the integral of 1 upon x? Log of mod of x. Mod is must, remember. Minus, as I explained here, 2 will come out, and inside the integral you are left with 1. And what's the integral of 1? Which is x, so 2x plus c. You differentiate 2x, you will get exactly 2. So this is your answer. Integral of given expression is this. So you have this function, division of two functions. We don't have division rule like differentiation. So what we do is here, 3 terms, single terms. So you can do individual division. This upon this, that is just x. X square will get cancelled, which is 5 minus 4 by x square. Now you can see each of these is a standard function here. What I did, individual division, these upon this upon this, this upon this. What is integral of x? x square by 2, you know. Raise the power by 1 divided by the same number. Here power is 1. What is the integral of 5? You know, 5x, because if I differentiate 5x, I'll get 5. Minus 4 into, this is actually x raised to minus 2 if I take into numerator. And what is the integral now? Minus 2 plus 1 upon minus 2 plus 1. So 4 into x raised to minus 2 plus 1 upon minus 2 plus 1 plus c, remember. Why integral of this portion is this? You take this one in the numerator, so it will be x raised to minus 2, raise the power by 1, so minus 2 plus 1 upon minus 2 plus 1. So finally you will get x square by 2 plus 5x minus, this is minus 1, so this will be plus 4. This is raised to minus 1, so I can write upon x plus c. So this is your answer. Question number 12, same way you do individual division. Question number 13 here. Question number 13, x cube minus x square plus x minus 1 upon x minus 1 dx. So here again division of two functions. We don't have division rule, that means this should get cancelled with the numerator. So what we do, we just factorize. You can see that here x square common, so x minus 1 here plus x minus 1 as it is upon x minus 1. We are just simplifying the function. This is not integration, remember. So x minus 1 will be common. Inside the bracket you are getting x square plus 1 upon x minus 1. Now this will get cancelled. So we are just left with here x square plus 1. And what's integral of x square plus 1? X cube by 3. Integral of 1 is x plus c. This is your answer, final answer. What is the important step here? You need to cancel x minus 1 with the numerator. So I took x square common, x minus 1, this is as it is. Taking x minus 1 common, so inside the bracket x square plus 1, this will get cancelled. You are left with this. Integral of x square is x cube by 3. Integral of 1 is x plus the constant of the integration. The next 15 number, again product of two functions. We don't have product rules, I'll just open the bracket. So 3 into here power 2, here power half, so x raised to 5 by 2, 2 and half, plus 2 into here power 1, here power half, so 3 by 2, plus 3 into x raised to 1 by 2. What I did? Nothing, just I took that root inside the bracket. So here power 2 and here half, so 5 by 2, here 1 and half, so 3 by 2 and 3 into this. Now each of these is a standard function, so you can integrate it. Raise the power by 1, 5 by 2 plus 1 upon 5 by 2 plus 1, 2 into 3 by 2 plus 1 upon 3 by 2 plus 1, plus 3 into x raised to 1 by 2 plus 1 upon 1 by 2 plus 1, plus the constant of the integration, that's plus c. So you just simplify. This is nothing but here 7 by 2. So you can write 2 by 7 into x raised to 7 by 2. This is 5 by 2. So 2 into 5 by 2 into x raised to 5 by 2. This is nothing but 3 into, this is 3 by 2. So 2 by 3, x raised to 3 by 2 plus c. So finally we'll get the 6 by 7 into x raised to 7 by 2. This is 5 into x raised to 5 by 2. This is 2 into x raised to 3 by 2 plus c. This is required integral of the given function. Okay. Question number 16 there. All are standard functions. 2x minus 3 times cos x plus e raised to x. 3 functions, but all are standard functions. 2 as it is. Integral of x is x square by 2. 3 as it is. Integral of cos is sin x. Integral of e raised to x is e raised to x plus c. So finally x square minus 3 times sin x plus e raised to x plus c. This is required integral. 17 is also like this only. Go to question number 18. There you have sec x, inside the bracket sec x plus tan x. So I'll just open the bracket because this is a product and we don't have product rule. So I'll get the sec squared if I open the bracket plus sec x into tan x. And now you can see that the both are standard functions. What's the integral of sec squared? You know it is tan x because derivative of tan is sec squared. What is integral of sec x into tan x? It is sec x because derivative of sec x is sec x into tan x plus c. So this is required integral here. So the first obvious step is you reduce into sine cos. So this will be sine square and this will be cos square. So this is just tan square, you know. This is tan square, sine square upon cos square. Now tan square cannot be integrated, but instead of tan square you can write sec square x minus 1, remember. You know this identity, 1 plus tan square theta equals to sec square theta, right? So what is tan square? That is sec square minus 1. Now you know integral of sec square, which is tan x. What's the integral of 1, which is x, because derivative of x is 1 plus c. Right. So we use this. Same way, if you want to integrate, for example, cot square directly you cannot integrate. So what we do, we use this identity, 1 plus cot square theta is cosec square theta. So here instead of cot square you can write cosec square x minus 1, as we wrote in case of tan square. Now you know integral of cosec square. What is that? It is minus cot. Derivative of cot is minus cosec square, so that gives you plus. Minus integral of 1 is x plus c, right? So if you have in integration tan square, use sec square minus 1. If you have cot square, use cosec square minus 1. So you have these two integrals, remember. If I go to 20th number now, integral of 2 minus 3 sin x upon cos square. Now again you have division of two functions, so it cannot be integrated directly, but you have two terms in the numerator, one term in denominator. So what's the obvious step? Individual division. 2 upon cos square minus 3 sin x upon cos square. This is very standard technique in integration. So this is equals to here 2 as it is. So 2 sec square minus 3 as it is. Sin by cos, which is tan. One more cos you are left, which is sec x. The whole dx. What I did? Sin by cos, which is tan, and one more cos you are left. 1 upon cos is sec. Now both have standard functions. 2 constant as it is. Integral of sec square tan x minus, what is integral of sec x into tan x, which is just sec x plus c. So this is your integral. 21 question. You want integral of root x plus 1 upon root x. So here this is nothing but just x raised to 1 by 2, and this, if I take in the numerator, it is minus 1 by 2. So now you can integrate very easily here. Raise the power by 1, 3 by 2 upon 3 by 2, so into 2 by 3, plus raise the power by 1, minus 1 by 2 plus 1. So it is just 1 by 2 upon 1 by 2, so into 2 plus c. This is your required answer, remember. Okay, question number 22. Here in this question you are given d by dx of fx equals to 4x cube minus 3 into x raised to minus 4. This is given to you. The question is find fx. This is the question. Get this fx. So we want to remove this d by dx. So we need to use antiderivative procedure, that is integration. So we just integrate it. So integral and d by dx gives us just fx. Here integration. So 4x cube minus 3 into x raised to minus 4 the whole dx. Integration and differentiation will get cancelled. Here fx in integration on this side. 4 as it is. Raise the power by 4 minus 3 into raise the power by 1. So minus 4 plus 1 upon minus 4 plus 1 plus c. Remember, don't forget to put this plus c. So this is x raised to 4. This is minus 3. So this gives us plus 3 and this will get cancelled. So you are just getting x raised to minus 3 plus c. This is fx. Now you are also given that f of 2 is 0. So from there you will get the value of the constant c. This is not the alternative given in this. You need to get the c. Now use this, so you'll get the c here. I'll put 2 here. So f of 2 equals to, this is nothing but the 2 raised to 4 plus here 2 raised to 3 plus c. And this is 0 here. Remember, what is f of 2? That is 0. So here you will get, if I take LCM, 2 raised to 4 and 2 raised to 3, 2 raised to 7 plus 1 by 8 plus c. So what is c from this? That is here on the other side, this is 129 by 8. 2 raised to 7 is 128. So this is c. This c we are going to place here finally. So f dash x equals to x raised to 4 plus 1 upon x cube minus 129 by 8. This is your final answer.